Come on. Okay, so Unit 7, Day 8. I don't know what my thing is doing. Let me stop. Okay, it says I'm recording. So, maybe my pen will work. It's been acting crazy. Okay. Unit 7, Day 8. We're going to learn about something today called the law of signs. The law of signs. So, obviously, we're going to use signs for law of signs. Now, let's just talk about stuff within a triangle. Angles are named with capital letters, and the sides are named with lowercase letters. Okay? And do you see how, like, the little a for the side for this segment BC is across from angle A, and little b is across from angle B, and little c is across from angle C. Y'all see that? Okay, that's important. Okay, that's going to be important to law of signs. Also, law of signs works for triangles that are not right triangles. So all the other triangles we have dealt with in this unit have been right triangles with a 90-degree angle. In law of signs, you do not necessarily have to have right triangles. They can be any triangle. Okay? So law of signs will work with any triangle. So that's your clue that you're going to use law of signs probably if you have a triangle that's not a right triangle. If you don't see a right angle in it. So it says we have practiced using trigonometric ratios to find the side lengths and angle measures in right triangles. The law of signs shows the proportional relationships between angles and their opposite sides. It can be used to find side lengths and angle measures for any triangle. So yeah, we use sine, cosine, and tangent, SOHCAHTOA to do right triangles, to find missing sides and angles. We're going to use law of signs to help us do it for just a regular triangle that's not a right triangle. So it's a proportion. So given triangle ABC, the sine of angle A, okay, come on, pen, work with me. The sine, oh my gosh. My husband worked with this last night and tried to fix it, but now it's going to be goofy. Yeah, my tip is bent is my problem. Of angle A over the side of little a equals sine of angle B over little side B equals the sine of angle C over little c. So the sine of the angle over the length of the side that's opposite equals the sine of the angle of another one. Okay? Now you're not going to have 3 strung across. We're going to end up with just 2, but it just shows that these are all equal ratios. They're all proportional. Okay? So this might make sense after we see a problem. It's actually really simple. Law of signs is a simple concept. All right. So basically, you're going to use angles and their opposite sides. Angles and their opposite sides. So, for example, this side of 12, that's a length of 12, is opposite the 35-degree angle. Do y'all see that? And this X right here is the side opposite from the 71-degree angle. Okay? So the opposites go together. Does that make sense? So I'm going to say sine of 35 degrees. You always do the sine of your angle measure over the opposite side, which is 12, equals sine of 71 degrees. Come on, pen, please. I cannot do this. Over X. Okay, so you do the sine of the angle over the opposite side. Sine of the angle measure over the opposite side. And it's a proportion, right? So remember proportions, we cross multiply. Okay, so cross multiply. So on one side, we'll have X times sine 35 degrees equals 12 times sine, come on, 71 degrees. And you're solving for X. So how do we solve for X? Good. Divide by sine of 35 degrees. I'm trying to. Okay. So in our calculator, I need to get a calculator. Y'all give me a second. Make sure we're in degree mode. Yes, that's important. So when mine wakes up, that's the first thing I'm going to do is check the mode and clear it because there's a bunch of junk in there. Mode degree. All right, second quit, go back home. Oh, that's cool. Did y'all do that? If you have the color edition, it does. But I just do that kind of to show y'all how to do it too. But yeah, thanks for pointing that out to me. All right, so you're going to type in what was in that numerator, 12 times sine of 71 degrees. Now, we know angle measure, so we're not using inverse, right? Close your parentheses. That's important. Divided by sine of what? Sine of 35. Now, law of sines, we're only using sine, not cosine, not tangent. I'm trying to hit 35. My pen is really not working. Hit enter. We're getting about 19.8. Y'all agree? So x is approximately 19.8. Now, if you know units, you put your units. Come on, Ken. But we don't know any units, and these are not angle measures, so you can just leave it 19.8. And here's a little clue, y'all. The smaller angle is going to be across from the smallest side and vice versa. 35 is a smaller angle than 71, isn't it? Yeah, so 12 has got to be smaller than 19.8. Does that make sense? Smaller angles are across from smaller sides. Okay, so that's how you do law of sines. You set up a proportion using opposite angles with opposite sides, and it's sine over the angle over the side equals the other one. Okay, now, okay, number 2. Do we know all of our, do we have a pair of opposites? Well, x is opposite what angle measure? 114, and 5 is opposite what angle measure? 18 degrees. All right, so we're going to say sine of 114 over x equals sine of what? 18 over, what's its opposite? 5. So any questions about how we set up the proportion? All right, then we solve the proportion. I should have wrote it up there. So on one side, I'm going to have x, x times sine of 18 equals 5 times sine of 114. So how do I get x by itself? Divide by sine of 18 degrees. Come on. Okay. So in my calculator, I'm going to hit 5 times sine 114. Oops, sorry, wrong thing. Come on. 5 times sine 114 divided by sine of 18. Did y'all get about 14.8? All right, let's see if that answer makes sense. So 114 is a bigger angle than 18, right? So my x needed to be bigger than 5, and it is. Does that make sense? Okay. Skip to number 4. Number 3 is just the same. Number 4 is a little bit different. So the 27 is across from what angle? 96. The X is across from what angle? We don't know. We don't know. So our first job is to find out what this angle is. Do we have enough information in our triangle to find out that angle? Yeah. How do we do that?
I have the 2 off and then 6 off.
Right. Triangle sum theorems tells me all the angles of a triangle have to add to be 180. So I can add the other 2 and subtract from 180 to get that missing angle. So sometimes you have to do that. So 53 plus 96 is 149. 180 minus that is what? 31. So we're going to use 31 for our angle right there. Okay? So we set it up. Law of sines. So sine 31 over x equals sine of what? 96 over 27. So we're not going to use that 53-degree angle because I don't have a side that's opposite. Does that make sense? You got to use opposite angles with opposite sides. Cross multiply. So you have x times the sine of 96 equals 27. Come on, pen. Sometimes if I rotate it, times the sine of 31. Right, and divide by sine of 96. Approximately. All right, y'all do that in your calculator. 27 times sine of 31, close parentheses, divided by sine of 96, close parentheses. What'd y'all get? About 14.0, if you round it. And let's check and make sure that makes sense. Did everybody get that? Okay, because I didn't show y'all my calculator punching. Is that okay? Did everybody get it? All right, so y'all check with me. 31 is across from my 14, and that's a smaller angle, so my number should be smaller than 27, because 96 is a bigger angle. Okay, so smallest angles are across from smallest sides. All right. Can y'all try number 5? Y'all try number 5. Like that one, you try. Need help, let me know. Check it with somebody when you're done. Round the decimal. Okay, so what angle goes with X?
The missing angle.
All right, how do you get that third angle? And what'd y'all get?
48.
So this angle is 48, right? Okay, if I can hold my pen just right, it'll work. There we go. So did we say something like sine of 48 degrees? God, this is on my nerves, y'all. I'm trying to be patient, but it is over what? X equals sine of, hang on. Okay, sine of what? 29 over 15. Why don't you use 103? Because we don't have a side opposite from that, right? We just needed that angle to get the missing angle, basically. So cross multiply. On one side, you'll have X times sine of 29 equals 15 times sine 48. Then what do you do? I'm trying to. Okay. Let's divide by sine 29. And what do we get in a calculator? Did it round to 23?
Yes.
23.0?
Yes.
All right. Okay. So let's make sure that makes sense. The 29-degree angle is across from 15. 48 is bigger than 29, so 23 is bigger than 15. Does that make sense? So raise your hand if you got that. So any questions about how to find a missing side using law of sines? All right, we're going to flip to the back and work on finding missing angle measures. So go down to number 9. Go down to number 9. So notice that our X is an angle measure this time, right? So if we, okay, eventually we're going to have to do what if X is an angle measure? Use the inverse sine function. Very good. So that's going to be a slightly different calculator punch when we get there. So first, let's just set it up using law of sines. So sine of X over what? 9 equal, seriously, this is so frustrating. Equals sine of what angle measure?
77.
Over its opposite side is 14. Seriously. There we go. Okay. Cross multiply. So on one side you're gonna have 14 times sine x equals, on the other side you'll have 9 times sine of 77. Now how do you think we're gonna do first to get x by itself? Divide by 14. Come on. Please. So the 14s cancel. Y'all? I'm trying. So sine x equals 9 times sine 77 divided by 14. Now, the best thing I think to do is use your calculator. Y'all with me?
Yes.
Okay. The thing I think is best to do is go ahead and type that in your calculator. 9 times sine 77, close parentheses, divided by 14, hit enter, and you get that decimal. Did everybody get that decimal? Okay. Now, instead of rounding that, we're going to make our calculator store it for us. Okay? So we want to take the inverse sign of that because we're finding x, right? Right? And x is the angle measure. So while we have it in our calculator, we're going to hit seconds. Don't clear that out. Have that in there. Make sure you hit enter and you have that big decimal. Hit second sine. And there you have your sine inverse, right? And if you hit second and then answer, which is that little negative beside the enter, it'll put the word answer in there. And that means it is putting in the previous answer. Okay? And you can close parentheses and hit enter. So that's telling me it's about 38.8 degrees. Okay? So hit second sine, second answer to do your angle measure. Okay? So that's about 38. Come on. Come on. 0.8 degrees. So do y'all see what we did there? We typed in that fraction. I wish I could do split screen, but I can't. You typed in that fraction, 9 times 77 divided by 14, and that's where we got that 0.6 number. All right? And then we did the inverse sign of that to get the angle measure. So second sine, second answer, saves that in. Okay? So y'all, with practice, this will be like nothing. Okay? All right. Let's go ahead and do a cross and do number 10. Because they really get no harder. It's just the same thing over and over. All right, so y'all tell me using law of sines, how can we set up our proportion? Let's just start with x. Sine of x over 15 equals, like when my pen's doing it, I have to just keep stroking with it, equals sine of what? 126 over 31. So is everybody okay with how we set up that proportion? All right, now we got to solve this proportion in terms of x. So on one side, I have 31 times sine of x equals 15 times sine of 126. And then how do I get rid of the 31? Divide by 31 on both sides. So sine of x is going to equal this fraction, 15 times sine, come on, of 126 over 31. So that's what we're going to type in our calculator. 15 times sine 31 divided by what? What did we say? I mixed that up, didn't I? The 15 sine 126. Yeah. 126. Oh, everything went away. Sorry. 15. It's not even let me tap it. 15 times sine 126. Close it. Come on, fat fingers. Well, mine is today. Divided by 31. Enter. And you got that decimal, right? But we need an angle measure, so what do we do? Second sine, second answer. And I think you can do it without parentheses, but I do it just to be sure. Did y'all get about 23.0 degrees?
Yes.
Okay. So x is approximately. Come on. I just want to write the answer. Like legit. X is approximate. Won't throw a hissy fit. I'm sugar flipping like crazy. Oh, there's one. Ugh. Ugh. I cannot. Y'all write the answer. Pretend it's there. X is approximately, what do we say, 23 degrees? 23.0 degrees. Sorry, people trying to watch this. Oh, come on. I want to write it so bad. I can't do it. My pen. Yeah, my stylist is. Oh, yeah. Come on. Come on. Whew. Yeah.
Instead of doing the whole like answer, like just sign and verse all of it, and then like it's the same answer.
It is, but it's extra calculator punching. You got to get your parentheses just right. But yes, you can. Just get it right. Okay? All right. As long as I see this work on your paper, I'm good and you get it right. Okay? All right. I want y'all to try a couple on your own. Why don't y'all just skip down and do number 13 and number 14? No, I want y'all to do 13 and 14. And I'm going to sit here and try to see if this will do anything. Yeah, I'll try 13 and 14 because they're the same over and over. It's the same. You find sides one way, you find angles using inverses. That's it. If y'all need additional examples, I'll be glad to provide them on the board. I'll do them both. I can't remember it. 59.1. Oh, come on. Did y'all get approximately 59.1 degrees for number 13? Y'all, I'm trying to write it on my board. I was working fine and I swapped over to the calculator and it won't let me finish it. Well, yeah. Y'all, I just want to write my 9.1. Here we go. Come on. I've twisted it and done it. Come on. Every time I get to where I can write it, my eraser button works on it. There we go. Come on, come on. Point. Oh, this is painful. I really want to scream. All right. So y'all got about 59.1 for number 13, right? Right? Y'all need participation. Did y'all get about 59.1 for number 13? Did you set it up like me? Okay. So, did everybody set it up like this? Okay. All right. So, I'm just going to have to do the other one on the board. Sorry for the people watching the video. Come to school. There you go. This one's 7, 82 degrees. This is X. Degrees. And that one's 18. So how do you set up this ratio for law of sines? Sine of X over 7 equals sine of 82 over 18. So the angles over the opposites. So on one side you have 18 times sine of X equals 7 times sine of 82 degrees, right? And then how do you get rid of the 18? Divide by 18. And then you have sine of X equals that fraction, 7 times sine of 82 divided by 18, and then use your calculator. And then you do the inverse. So X is approximately what? 22 point. Did everybody get about 22.7 degrees? And if you check and see if that makes sense, 82 is bigger than the 18, so 22.7 should be smaller than 82 because 7 is less than 18. All right. That was the end of notes for today, and that was painful. Sorry. Have a good day. If I can even